So we know that it is possible for a determinant matrix to end up being zero. It's definitely not far from the ordinary. But when it comes to evaluating determinants, what are some telltale signs that will instantly tell you a determinant is going to be zero? And there are three rules or three indicators that will foreshadow a zero determinant. So the first one is this one right here. So let's say we have a matrix C. Now, what's the relationship between columns 1 and 3? And it turns out that they are multiples of each other. And by what value? Well, negative 3. Does it matter? No, because when we're taking determinant, the third rule was that if one row or column is multiple of each other, that will yield a zero determinant. And there you have it. We went through three numerical examples demonstrating the conditions that yield a zero determinant. Now, can we do one more example for this? Except it's going to be a little more nuanced. Can we do that? I hope so. So let's say we're given this matrix right here. So none of the three rules immediately stick out to us. We are going to have to put in a little bit of grease. So how are we going to find the determinant of this matrix? Well, it turns out we're going to have to do some math. And what if we could manipulate it? What if we grab the first row, multiply by -2, and add it to the second row, and bring all that change to the second row? What that looks like numerically, well, it's -2 times row 1 plus row 2, bring the change to row 2. Alright, go ahead and pause the video, and do the math. And if you want to follow along, that's okay. Turns out we get the following results right here. And turns out there's something sticking out. What's unique about rows 2 and 3? And it turns out they are multiples of each other by a value of -2. And based on that information alone, we can deduce that the determinant of A ends up being 0 based on that fact. And there you have it. We were able to solve a matrix with a 0 determinant, as well as brief ourselves with the conditions that yield such a result.